Okay, hopefully the video on dilations yesterday was helpful. I always think that the first example they used about your eyes being dilated is helpful. It's going to be the exact same shape, but a different size. I found this worksheet that I thought would be useful to look at how we apply a dilation, or if it's already happened, how we could find the missing scale factor. So one thing I'm going to fill in, the variable that we use for the scale factor is K. Let's see if I can make that neater. Scale factor should be K, and we use multiplication to apply a scale factor. Here we don't know the original points. I don't know what the coordinates of A would have been, but I know the image. After a transformation, we get to A prime at 8, 12. If my original point, whatever the coordinates of A are, were multiplied by 4 to get to A12, to work in the other direction, we'd have to divide. So 8 divided by 4, the x coordinate would be 2. 12 divided by 4, working backwards, we'd know that the original y value was 3. On the next problem, I have the original coordinates, p and q. I don't know the scale factor, but I know the image is at p prime and q prime. The first thing I'd want to notice is that the numbers get smaller. So one thing we learned from the video, that means my scale factor is going to be less than 1. Here, 14 divided by 2 is 7, so I would want to think about that as a fraction. My scale factor is going to be 1/2. Another way of saying to divide by 2. Let's see. Okay. Here, even if it's a decimal value or if it's fractional, we're going to be able to figure out the dilated points. Here, I would take each value, I'd multiply by 3.1 to find the image. Let's see. The only other thing I wanted to mention was that when we look at a problem, if a number is greater than 1, we know it's going to be an enlargement. If something is smaller than 1, we know the value is going to get smaller. That shape will be 2/3 the size it originally was versus almost 3 times or more than 3 times as large.